So our goal in this video is going to be for you guys to understand how motion can be graphed. So one of our standards is understanding motion graphically, and to do that we want to be able to talk about them or an object that moves in terms of position and velocity. And we can actually get pretty similar information from those two types of graphs depending on the motion. And so our goal is to be able to say, with a given motion, can we graph that motion on a position time graph? Can we graph it on a velocity time graph? And vice versa, if I see one of those two graphs, can I backtrack and determine an object's motion? With that, let's break them down. So, with our two graphs here, we've got position or distance, and we've got velocity. And so how we're gonna distinguish those two things, of course, is on our axes here. And I would put position or distance, which would be a change in x, position, typically in meters. And on the bottom, we'll go with time, typically in seconds. On our velocity time graph, very similar, right? Velocity, typically in meters per second, a distance over time, and then time, again on the bottom, again in seconds. So with a no motion situation, you're at some position, and if you're not moving, you would stay at that position. So we could plot that over time, standing in that single position. For a velocity time graph, it does not tell us what position you're standing in, maybe that may be 1 meter, but it does tell us that you're not moving, and so we'd end up down here, directly on the 0 axis, because you're moving at 0 meters per second every second. Now, if you're moving at a constant motion, we can graph that change on a position time graph. So maybe you are moving at 1 meter every second. Right. I would say, okay, well then if I start at the 0 point, I would be here. If I moved 1 meter in 1 second, I'd be here. Another meter in another second, you'd be here. And that trend may continue. And we can see from this graph that you're moving away from the origin and that you're moving in a positive direction. And if we were to make that a linear path, we could see that you're moving 1 meter per second. Again, that would be like a rise over run situation. And we can measure that and graph it. What that looks like on a velocity time graph is very different. Here we see we're moving 1 meter per second and changing position away from the origin. But in a velocity time graph, if I go putting these distances as 1 meter per second, we're going to get a very different graph. So I'd say, okay, well in the first second, how fast was I going? 1 meter per second. In the second second, how fast was I going? 1 meter per second. In the third second, I'm maintaining that same velocity. And so we should get a straight line across our graph in a velocity time graph telling us we're constantly moving at 1 meter per second. So in our next scenario, you might be accelerating or speeding up as you go. So in the first second, maybe you've gone 1 meter in a second. But the next second, you've gotten a little bit faster. And you may have traveled 2 meters in the next second. If you continue that pace, you might continue, and over the next second, you travel 4 meters. Right? And we can continue this trend on up, and we end up with a very different graph. It's no longer linear, but curved. And this tells us, of course, we're still moving in the positive direction every second, but that we're changing a greater distance or position every second. If we move to our velocity time graph, we can get the same information present, but it'll look very different. In that first second, we went 1 meter per second. In the second second, we went 2 meters per second. In the third second, we went 3 meters per second. And so with that trend, we could say you are getting faster every second. In this graph, we do not have a curve, we have a straight line.